Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everyone, dear academics. Welcome to our third international conference on water problems in Mediterranean countries and sixth international conference on natural resources and sustainable environmental management. This is room 2, session 2. We have few lecturers ready to present, and every lecturer will have 15 minutes of time allocation. And our first presenter is Dr. Nrsem Menemenci.
Everyone, I am Professor Dr. Nrsem Bahçelerli, and today I will present our paper with my colleagues, Assistant Professor Dr. Salim Akürek, the contribution of smart cities to sustainable tourism and becoming a smart tourism capital. Advances in the field of information and communication technologies in the 21st century have led to emergence of existing applications such as smart cars, smart homes, smart schools, smart hotels, and smart cities. The concept of smartness has been brought to the beginning of almost all concepts. So, what is smart? Smart analytics, modeling and visualization to ensure the integration of the real-time data with each other, the sharing of integrated data and the optional use of integrated data in the decision to be taken. And when you look at the smart city, the question we are interested in, how should smart tourism be? In order to explain the concept of the smart tourism and to define the tourism practices as smart, we first need to clarify the concept of smart city. So if you look at the explanation of the smart city is a concept that emerged in order to prevent confusion, chaos, and management difficulties that arise due to the increase in population, rapid urbanization, traffic, environmental pollution, unconscious consumption of resources, etc. And also smart cities, the important points, it should be support the effective and efficient use of resources, fair and equitable governance practices, sustainability, quality, and standardization. If you look at the definition of the smart city, who make ISO International Standard Institute, they define the smart city as a new concept and new model in which next generation information communication technologies are applied in planning, management, construction, and services. The concept of intelligence attributed of cities includes the effective and efficient use of resources, fair and equitable governance practices, and efforts to use new and innovative technologies, I said before, for sustainability, quality, and standardization. When we talk about smart cities, we are talking about the city where new generation information technologies, sensors, and equipment are applied to hospitals, roads, bridges, tunnels, buildings, dams, water and sewage lines, access to touristic and historical sites. Of course, via the internet. And in another definition said that the smart city by technology, it means that the city becomes a whole and creates synergy with the social components of the city. When we look at the key components of the city, there's a 6 key components of a smart city. These are smart people, smart environment, smart governance, smart life, smart economy, and smart transportation. However, as always, the human factor is at the center. Smart people should be perceived as people who are educated, participatory, creative, active in social life, and whose learning process continues, becomes smart cities will be created by smart people. When we look at the smart governance dimensions deals with the transparency with the governance system through the modernization of city management by supporting data sharing and public participation. Smart environment is related to energy management that enables sustainable management of existing resource. When we look at the smart mobility, it's related to the accessibility within the and outside the city and the availability of modern transportation system. Smart economy, it relates to the implementation of economic strategies based on digital technology. Smart people I also define, and when we look at the smart life, it includes the quality of life can be measured in terms of healthy environment, social cohesion, touristic city, cultural and educational services. From smart city to smart tourism. Smart tourism is one of the goals of the smart cities. Developments in technology have closely affected tourism as well as many other sectors created the concept of smart tourism. We can say that the cities are getting smarter in a way that will change the perspective and understanding of tourism. We can see that the cities that attract the most tourists in the world and the cities at the forefront of smart cities this match each other. Therefore, smart cities are becoming destinations that will offer enhanced tourism and travel experiences. And you can see some of the examples of the smart cities all around the world. And if we look at the definition of smart tourism is defined as a tourism system that utilizes smart technology to create, manage, and deliver smart tourist experiences, including tourist activities supported by ICT and smart technologies. If you look at the information and communication technologies have added value to visitors' experience and increased competitiveness in tourism destinations. In particular, the speed of the development of smart cells phones is much faster than other technologies. Tourists frequently use smart phones as a means of obtaining information during their travels because they are easy to carry, inexpensive, and have ability to connect the networks wherever they go. With mobile phones, they can easily maintain their personal communication, follow and continue their daily work, and access the information they need about the touristic regions they visit through mobile application. In other words, mobile phones act as a portable guide in a sense. And the figure is show us the structure of smart tourism. A smart tourism system consists of 5 elements: the tourist, information exchange center, government, natural areas, and business. The information exchange center monitors and evaluates tourist requests such as ticketing, reservation, communication, and sends the results back to the information requester. The Information Exchange Center is also responsible for monitoring natural areas in real time, and the results of the daily visits are statistically analyzed and achieved on the one hand and transmitted to government sources as a basis for future policy and planning on the other. Tourism businesses can also request the Change Center to disseminate information to tourists through advertising and promotion. In order for a destination to be considered smart, it needs to implement some practices. So we can list some of these applications as follows. In terms of tourism attractiveness, historical and touristic places can be digitally modeled and tourists can gain experience with augmented reality applications. With virtual tracking system, instant data information of transportation system can be provided and shared with tourists instantly. Smart traffic control system and smart public transportation system can be established. Smart electric vehicle charging system, bicycle charging points, smart parks can be established. Smart cameras and security system can be created. Smart advertising and promotion applications, performance and event announcement can be created. For tourism business, energy needs can be estimated with the smart application and smart management of energy saving system can be provided. Free Wi-Fi services can be made accessible to all visitors. Multilingual digital travel guides can be created and every mobile device can be turned into a guide. Unmanned tourism information and information kiosks can be placed in crowded parts of the city. Smart city card application and contactless city payment system can be created. QR codes and NFC tags can be used to access information in historical and touristic places. Complaint management system can be carried to tourist mobile devices and can be instantly delivered to solution provider authorities solve. And smart health systems, smart municipal services, smart application for barrier-free life, smart environmental system can be created. So, becoming a smart tourism capital. For becoming a smart tourism capital, there's a fourth category that is very important. The cities should be accessible and city should be sustainable. Digitalization and cultural heritage and creativity is important point for becoming a smart city capital. And first criteria for becoming smart city capital, city population should be 100,000 or more. And the other four categorizes is all practices should be based on sustainability. It should be accessible to all regardless of social or economic status, disabled or non-disabled. Use the possibilities of digital technology. And the last one, use their cultural heritage and creative industries in their tourism experience. If you look at the year by year, the smart cities capitals, in 2019, Finland, Helsinki, and France, Lyon won the EU Smart Tourism Capital Awards. Also, Malaga in Spain gained the awards from the accessibility. Ljubljana, Slovenia is gained through sustainability. Copenhagen in Denmark is digitalization. And Linz, Australia gained the awards from cultural heritage and creativity criteria. In 2020, the cities of Gothenburg in Sweden and Malaga in Spain won EU Smart Tourism Capital Awards. And in sustainability, also the Gothenburg gets its awards in accessibility, Breda in digitalization, Ljubljana in Slovenia, and the cultural heritage and creativity, Karlsruhe in Germany get these awards. In 2022, Spain, Valencia, and the France Bordeaux cities won the EU Smart Tourism Capital Awards. Venice Sustainability, Ljubljana in accessibility, Dublin digitalization, Florence cultural heritage and creativity, and one more criteria added in 2020, favorite destination, also Palma in Spain get these awards in 2022. And when we look at in 2023, Cyprus, Paphos, and Spain several cities won the EU Smart Tourism Capital Awards. In sustainability, Aarhus, in accessibility, Gijon, in digitalization, Porto, in cultural heritage and creativity, San Sebastian, and the favorite destination awards goes to Zagreb. And when we come to the conclusion, developed countries have utilized the opportunities of technology to the fullest and or to promote their tourism access by providing more information in shorter periods of time and lower costs. and countries, regions, and cities using traditional methods have less and less chance to compete with those using advanced technologies. In the near future, it's predicted that tourism regions will be divided into developed and underdeveloped tourism regions according to the rate of use of information and communication technologies. For this reason, tourism destinations should engage in research and implement their production. As a result, tourism destinations in Turkish tourism should increase their steps towards rationality and highlight their existing potential by following the results of new developments in tourism. In short, it's necessary to know the whole, but act locally for the benefit of the country and people. Thank you for listening, and thank you for opportunity to present our paper in this conference.
Thank you very much, Dr. Nesrin Menemenci, for your valuable research. Our next researcher is Dr. Shohbatul Fadilah.
For various purposes. It depends on the location, quantity. Good afternoon, ladies and gentlemen. I am delighted to be here today to share our research with this distinguished audience at the 6th International Conference on Natural Resources and Sustainable Environmental Management 2023. I am Shohbatul Fadilah from Department of Civil Engineering Universitas Islam Indonesia, and my partner Fitri Retnawati from Department of Public Works and Water Resources of East Java Province, Indonesia. This is a brief of content of the presentation. The first is introduction. The precision of rainfall observation data plays a crucial role in determining the quality of hydrological analysis for various purposes. It depends on the location, quantity, and pattern of network distribution. Several approaches have been developed to determine network distribution pattern effectively and efficiently, such as rationalization method. So, this research aims to evaluate the rationalization of rainfall station in the Bedadung watershed using the WMO and kriging method. This is some of literature review in 2019, Pramono et al. Conducting a research about rationalization of rain station in Ciliwung Cisadane River Basin using WMO, kriging, Kagan, stepwise, and quality control methods. About the results, based on the WMO standard, the density of rain station in the Ciliwung Cisadane River Basin was still quite adequate. Based on the stepwise analysis, there were 11 influential rain stations. Based on the Kagan analysis, an error value of 10% need 23 stations with a distance between of 16.23 km, and an error value of 5% need 90 stations with a distance of 8.21 km. Based on the quality control analysis, there were 14 rain stations in good condition. In 2020, Hermawan et al. Conducted a research about analysis of rain gauge station distribution with stepwise, kriging, and WMO methods in Serang watershed, Central Java. They used stepwise, kriging, and the WMO methods. The result of rainfall distribution analysis in Serang watershed using stepwise and kriging methods show that the distribution is good, which is shown in stepwise method with value of R coefficient among variables approach 1. Based on the WMO standard, the area of influence at each station does not meet the standards. And also in 2023, Ardana et al. Conducted a research about rationalization of regional rainfall station network in the Tukat-Mati watershed. They used the WMO and Kakan-Roda methods. From their research, the analysis using the WMO standard found that all rain stations were less than the minimum density. Meanwhile, from the Kakan-Roda method, it is recommended that 4 selected rain stations out of 6 rain stations. Our research study area is in Bedadung Watershed, Jember, East Java Province, Indonesia. Our research is a quantitative research that needs data, consists of rainfall data for 13 years from 2004 to 2016. The second one is spatial data in the Bedadung Watershed, and also other related data from Department of Public Works and Water Resources of East Java Province. And for the data analysis, we used the WMO and Kriging methods. This is the difference between the WMO and Kriging methods. The WMO is the easiest method offered by the World Meteorological Organization, which combines topographic elements and the area of influence of its hydrological observation post for rainfall station. This is the table of minimum rainfall station network density. And the Kriging is a strong statistical interpolation method that is very useful in areas with a great complexity in climatology and geomorphology. The density network analysis using Kriging method to obtain the effective number and placement of the station. Kriging analysis was conducted after determining the variogram. Actually, there are 3 types of variograms, consist of spherical, exponential, and linear model. And this is the result and discussion. Based on the analysis, Bedadung watershed have a category of tropical, Mediterranean, and temperature mountains regions with the area of the region per rain jet station about 100 to 250 km². From the evaluation result using the WMO standard, it can be seen that only Dam Tegal Batu and Dam Pelatakan rainfall station that have a rainfall influence area of 100 to 250 km² or meet the WMO standards within the Bedadung watershed, that is indicating a normal density. You can also see in the table, and I have give a green highlighter. Other rainfall stations have a rainfall influences area less than 100 km², falling below the minimum density or being too dense. Due to many stations having an area below the minimum, it can be concluded that the rainfall network within the Bedadung watershed is too dense. And this is the prediction map using Kriging method of Bedadung watershed. From this figure, we can say that if the color gradation is close to red, it indicates that the rain heading at that point meets the standards of the Kriging method. On the other hand, if the color gradation is close to blue, it indicates that the rain post or rain station at that point doesn't meet the standards of the Kriging methods. And you can see this is the table of cross-validation model semi-variogram spherical of Bedadung watershed. The minimum value of the relative error used in this research is about 5%, when the the relative error results less than 5%, it means that the rainfall station is appropriate with the kriging method. But when the relative error bigger than 5%, it means that the rainfall station doesn't meet or inappropriate with the kriging method. According to the kriging method, we can conclude that 27 out of 40 rainfall station positions in the Badadung watershed are considered appropriate with the kriging method. For the conclusion, the analysis result of the rationalization of the rainfall station network using the WMO method and kriging indicates that the station network within the Badadung watershed is excessively dense. According to the WMO method, only 2 out of 40 rainfall station positions meet the WMO standards. According to the kriging method, 27 out of 40 rainfall station positions in the Badadung watershed are considered appropriate with the kriging method. And then, for suggestion for further research, it is advisable to compare this research with other approaches such as the Gagan Roda method, stepwise method, and quality control methods. This is the end of our presentation. If you have any question, you can contact us via email. And thank you very much for your attention.
Thank you very much, Dr. Shohbatul Fadila, for your presentation and for your research. Now, our next presenter has discontinued from our last session, and right now, Dr. Ali Emir İnce can present.
Student from İzmir Institute of Technology from Turkey. I'm going to present a study titled The Importance of Transponder Aquifer, Case Study Güzelyurt Aquifer, with the contribution of Ms. Kibaroğlu and Mr. Baba. During my presentation, I am going to introduce the topic and give information about transponder aquifers, Güzelyurt aquifer, and my case study, and finally I will conclude my presentation. Water, a fundamental source of life, constitutes only about 2.5% of the Earth's surface as freshwater. Despite its abundance, only a small fraction of freshwater, approximately 30%, is accessible as groundwater. Groundwater, a critical resource, represents the most extracted raw material globally and is vital and secure source of drinking water. It serves as a shared resource that transcends political and geographical boundaries, making it transboundary resource. Unlike surface water, the management and visibility of groundwater have historically received less attention. The United Nations Economic Commissions for Europe initiated the first international effort to regulate transboundary waters in 1992. The Convention on the Protection and the Use of Boundary Watercourses and International Lakes define watercourses as a unified system of surface and groundwater flowing to the common endpoint. Currently, there are 592 identified transponder aquifers worldwide, as shown in figure. This global distribution highlights the importance of addressing cross-border groundwater challenges. In response to the escalating effects of global climate change, many nations need to formulate policies that align with their political, historical, economical, and social ties with their neighboring countries. In 1967, Helsinki Rules introduced the principles of equitable and reasonable utilization for the first time. The first agreement was made in 1978 for the Geneva aquifer located on the France-Sweden border. After that agreement, the political and legal dimensions of international transboundary groundwater have gained increasing attention. In the United Nations General Assembly in 2009, law of transboundary aquifers was adopted. In this text, transboundary aquifer or transboundary aquifer system is defined as an aquifer or aquifer system comprising parts located in different states. Today, there are several agreements are ongoing in various parts of the world. Some notable transboundary aquifers managed through the international collaboration and agreements include South America, North America, Saudi Arabia, West Africa, Mexico-US border, and Canadian, also US border. The common denominator in all these collaborations and agreements is that the countries involved commit to sharing all relevant data transparently and agree to manage the aquifer based on this information. Güzelyurt Aquifer in the Turkish Republic of Northern Cyprus and the Turkish Republic of Northern Cyprus is located downstream of the Korodos Mountains. The annual water usage of state is 107 million meters cubed, with 90 million from underground water source and 17 million meter cube from the surface water. The Güzelyurt Aquifer is the largest underground water source within the Turkish Northern Cyprus and is used to meet approximately 70% of the island's clean water needs. The average annual rainfall, which was 440 millimeters in the early 20th century, decreased to an average of 340 millimeters a year up to mid-2010. And also the increasing population, agricultural production, and climate change have led to continuous increase in the amount of water drawn the Güzelyurt Aquifer since the 1960s. The natural water table in the aquifer has changed so much that it has become lower than sea level, leading to entry of seawater. Approximately half of the basin in which the Güzelyurt Aquifer is located is within the southern Cyprus Greek-administrated region. Additionally, about one-third of the aquifer's surface area is also within the boundaries of southern Cyprus. According to 2002 data from the Center Cyprus, the annual average flow of water in rivers carrying water from Korodos Mountains to Güzelyurt Aquifer is approximately 39 million cubic meters. According to Water Master Plan published by the Center Cyprus in 2004, the total amount of water reaching the aquifer from Korodos Mountains is calculated to be 5.3 2 million cubic meters. The annual total recharge of the Güzelyurt aquifer is approximately 40 million cubic meters, while its usage is 65 million cubic meters. The Güzelyurt basin in which the aquifer is situated is also transboundary basin, and the Turkish Republic of Northern Cyprus is in the downstream position in terms of water flow within the basin. The water that should reach the aquifer from Torodos Mountain is being retained by dams constructed by the Southern Cyprus Greek administration, leading to insufficient natural replenishment of aquifer. 30 million cubic meters, the water from the Torodos Mountains, which is the natural replenishment source for the aquifer, has the potential to eliminate salinization and deterioration. Additionally, Çamlıdere River, which transports the water from the Torodos Mountains to the aquifer, has the only largest copper mine in operation on the island upstream of its flow. However, the two states neighboring on the islands do not recognize each other Moreover, although the United Nations and the other states view Southern Cyprus Greek administration as the sole official authority on the island under the name Republic of Cyprus, no state other than Azerbaijan and Turkey recognize the Turkish Republic of Northern Cyprus. The Turkish Republic of Northern Cyprus is not recognized due to its establishment through the use of force contrary to international law and in violation of international treaties. Nevertheless, these claims lack legal basis. The non-recognition of the Turkish Republic of Northern Cyprus on the international stage due to the deterioration of the Güzelyurt aquifers hindered seeking the justice internationally. In the United Nations Law of Transboundary Aquifers, which is the Southern Cyprus Greek administration is a member, Article 40 emphasizes that the aquifer should not be used to the degree that hinders its effective functioning. Furthermore, Article 5 lists the factors to be considered in the assessment of the aquifer, highlighting vital human needs. From this perspective, the degradation of the Güzelyurt aquifer due to salinization is related to Article 4 of the United Nations decision, and the use of the water from the aquifer both for human needs and agricultural irrigation is related to Article 5 of the decision. Although the United Nations decision is advisory in nature, it is binding on the Southern Greek administration. However, the non-recognition of the Turkish Republic of Northern Cyprus as a state allows the Southern Cypriot administration to remain indifferent to the issue. In its 210 decision, United Nations expressed the view that the access to water and sanitation is a human right. It emphasized that the member countries should respect the rights of all people to access clean water and sanitation. As a UN member, Southern Cyprus is responsible for the people using the Güzelyurt aquifer as a water resource based on this decision. Moreover, its status as the de facto authority for the entire island, widely accepted in international relations, indicates that it has already accepted this responsibility. Managing the limited water resources of the island of Cyprus, which faces increasing pressure from population growth and climate change, is critical for its sustainability. In this context, it is essential for the transboundary Güzelyurt aquifer, which is salinizing due to improper use and excessive extraction, to be collaboratively managed by both the Turkish Republic of Northern Cyprus and the Southern Cyprus Greek administration. To ensure the aquifer's healthy survival. However, the two neighboring states on the island do not recognize each other, making collaboration impossible. Additionally, due to the Turkish Republic, Northern Cyprus lack of international recognition, it cannot become a party to UN's law of transponder aquifers. On the other hand, within the framework of UN General Assembly decision in 2010 on the human rights to water and sanitation, which presents itself as the de facto authority, the Southern Cyprus over the entire island internationally bears the responsibility to ensure access to clean water and sanitation for all people living on the island. This includes the preservation and improvement of the island's water resources. The fair and reasonable sharing of water resources, which constitute the lifeblood of the island of Cyprus, requires a humanitarian perspective rather than a purely political one. The parties involved need to address the issue from a human dimension, considering the well-being of all people on the island. In summary, effective and collaborative management of water resources on the island is critical to resist the growing pressure created by the population increase and climate change. It is imperative that the transboundary Güzelyurt aquifer be jointly managed by Northern and Southern Cyprus nations, emphasizing a humanitarian approach over political considerations. Despite the current lack of mutual recognition between two states, finding common ground for the sustainable use and preservation of water resources is essential for the well-being of all the residents on the island. Thank you for your listening. Have a good.
Thank you, Dr. Ali Emir, for your presentation. Our next presenter is Dr. Ismail Abubakar Bobboy.
The chairman permit me to stand on the existing protocol. I am Ismail Abubakar Bobboy with the ID number 2023-4736, making a presentation on explainable model for prediction of chemical oxygen demand in industrial wastewater treatment plant facilities in Delzeel, the Netherlands. My presentation will start with background, that is the effect of raw sewage on both aquatic and public health. This picture is clearly showing the source of raw sewage or untreated water from the industry and from the residential or from the residential areas. The picture is clearly showing the effect of this raw untreated water on the aquatic animals such as fish, how it costs their life. And the last picture here by the right is showing people that are living very close to the contaminated area. The effect of raw sewage on both aquatic and public include the quality of water degradation. This is clearly and obviously known that when the pollutants are increasing, definitely the quality of the water will be degradation or reduced. Among the effects is the habitat destruction, as also known that aquatic animal, their habit is in the sea. So by discharging the untreated water in the sea will cause harm and destruction to their habitat. Another effect is bioaccumulation. This is going to affect the human being that are by consuming the products that have a direct contact with the contaminated from this raw sewage, and followed by waterborne diseases such as cholera, typhoid, hepatitis A, are all caused by the raw sewage or untreated water. We have another effect is groundwater contamination. This is our source of groundwater, such as well, pipe, borehole, pipe borne water. And so by discharging the contaminated raw sewage, that is untreated water into the environment, will cause our groundwater source to be harmful. Another one is the food safety concern. This is dealing with the product that has been generated from the irrigation. It's going to affect our life directly. This water treatment plant, what is it? The wastewater treatment plant is the process of removing all unwanted organic substance, all organic substance compounds that are unwanted from the used water before discharging it. The process of removing it before discharging it to the environment or to the water is called, it is known as wastewater treatment plant. This waste treatment plant, as been shown in this picture, is clearly showing the stages. It has some stages. Such stages are primary settling tank, activated, where is the first the settling of the sludge will take place, then activated sludge, then final settling tank, then disinfection, then the sludge disposal. The importance of machine learning in wastewater treatment plant. As all known that machine learning is an advanced, it is advanced technique which is very important when applied in the wastewater treatment plant. It is advanced technique that has capability and suitability to handle the process of wastewater treatment plant. When machine learning is being applied in wastewater treatment plant, it will produce so many advantages. Among the advantages, cost reduction. It will reduce the cost to the reasonable amount, because you can use the prediction, the simulated result generated, you can use it to implement, so it will cost less. It has high performance in both speed and prediction. That is, it will cause. It has a predictive maintenance. That is when in the process when there are some equipment that has a failure, the machine learning has the capability to predict that failure, so that it will be straight. It has the predictive maintenance. That is when it can anticipate an equipment failure. When there is equipment failure, the machine learning has the capability of predicting that failure straightforward. The process optimization, that is by analyzing the complex data. It has the capability of analyzing very complicated data, such as wastewater treatment plant data. So machine learning has the ability to identify and analyze this data. It has the anomaly detection. It has the ability to identify all abnormal conditions in the wastewater treatment plant. It will help in resource allocation. It will help you it will help in the process of maybe, for example, the chemical dosage used for the treatment plan. And it will help in the water quality prediction. The problem statement, there is existing problem. Okay, the problem statement, what are the problems related to wastewater treatment plan? The problem that is related to wastewater treatment plan is that the effluent, that is the outlet of wastewater treatment, water treatment plan quality will be reduced, mitigate due to the excess of chemical oxygen concentration. This will result to the decrease in treatment efficiency, increase in operational challenges, and increase in environmental harm to the high aquatic life. In order to solve this problem, so many techniques were in existence over the years, but the existing techniques, they were resource intensive based on the literature. Because if you want to build the water treatment plan, it will cost you a lot of money. If you want to use the chemical, it's very expensive. So they are resource intensive. Because of that, they are highly cost. So what is the solution needed? The solution needed is to develop advanced machine learning model, which is explainer based to predict the concentration of chemical oxygen demand, which is cost effective and high efficiency. The objective of this research is to develop 4 different advanced learning machine models, such as XGBoost model, CatBoost model, random forest model, and decision tree models. After developing this, then the sharp explainer will be incorporated into the models in order to predict, to interpret their prediction. Then the errors will be determined, such as mean average error, mean absolute error, mean square error, and R square to determine their fitness. The data source, the methodology, the data of not water saline wastewater treatment plan of Delzul, the Netherlands, was adopted for this research work. The data set was first correlated and the features were determined. The relevant features were determined based on the correlation made, the features that are significant to the output. Then the data set was split into independent and dependent variable. Independent variable, they are the variable that will not be affected by any change of any variable, while dependent variable, they are the variable that will be affected by the change in any of the independent variable. It was then further split into the training and testing sets. Then the training and testing set were used to develop XGBoost, CatBoost, random forest, and decision tree models. And this model, the sharp explainer were integrated to the model to interpret their prediction. Then the model prediction was created for the training and testing sets. Then the COD prediction was made, plots were generated, and errors such as MAE, MSE, and R square were determined for to evaluate their fitness. The table is showing the errors measures for both training and testing. For MAE and MSE, the lower their values, the better the model, while R square ranges from 0 to 1, the higher the value, the better the result. The table gives the clear picture of that. Then the XGBoost. This plot is the plot for the XGBoost, that is the scattered plots, which is showing the relationship between prediction and actual values for both training on the left-hand side and testing for the right-hand side. The red line drawn is the best line. That is which indicating that the blue point, the closer to the line, the better the model it is. This is for the training on the left, the testing for the right. And this is the feature value. That's the importance of explainer. It will show the features that has the influence to the output, the most influence to the output. The cat boost. This is the scattered plot showing the relation between the actual and the predicting value. They are linearly related. The varies directly varies. The higher the prediction, the higher the actual. This is for the trend. This is for the test. This is showing how the line, how the points fit into the lines. The closer to the line, the closer of the points to the line, the better the model. This is the features indicating the. This is the features, feature values indicating the features that has more impact on the output. This is for the random forest scattered plots showing how close the points to the red line. This is for the training, this is for the testing, this is for the feature, showing the features that has influence to the output. This is for the decision tree, the plots, a scattered plot, showing the relationship also between the actual and predicting values. For the training and testing, this is the feature showing which one has more influence to the output. This is the bar chart of the calculated error. It's showing that the maximum error is less than 0.12, means that the lesser the values for both training on the left and testing on the right, the better the model. It's showing that the XG boost has the is the better model because it has the least value of MAE for both training and testing. And then the conclusion, the advanced learning machine models such as XGBoost, CatBoost, and random forest decision trees were developed and employed to estimate COD. Then the best of them that predicted the COD was XGBoost. Then the Sharp's explainer clearly shows the features that influence the output. Then the model fitness were measured to be more than 90%. Thank you for listening.
Thank you, Dr. Ismail Abubakar Bopoy, for your presentation. Now, our next researcher is Dr. Mohammed Pejani.
Hi there.
Hello. If you are ready, you can present.
Yes. Do you have my screen now?
Yeah, everything is perfect.
All right. Hello, everyone, and welcome to our presentation, which is titled Assessing the Soil Erosion Rate of Clay County, Minnesota, using Revised Universal Soil Loss Equation, or Russell in brief, which is conducted by Professor Noorani, Mohammed Pejani, Hadi Purali, and Dr. Hosseini Baghan. The table of our presentation as follows: introduction, literature review, research questions, methodology, results and discussions, and finally conclusions. Let's start with the definition of the soil erosion. The soil erosion is a kind of natural disaster that leads to removed topsoil layer, which consists of mineral and organic matter by different factors, such as wind, water, ice, and gravity. And there is serious cause of soil erosion that finally leads environmental issues such as reducing agricultural products, increasing river sediment, degradation of water, and more importantly, desertification of lands. As I mentioned in the title of our presentation, we use Russell model, which considers water erosion. There are 4 types of water erosion, but Russell model considers 2 of them, which are sheet and reel erosion. At the first stage of water erosion, the splash erosion occurs. This erosion occurs when the raindrops hit the bare soil, causing the soil particles to move around and from their original place. It may move vertically and horizontally. If this type of erosion is not controlled, it may cause severe types of erosion, such as sheet and reel erosion. Sheet erosion, on the other hand, is more advanced than splash erosion, which the layer of thin water covers the large area of soil and washes away all the essential minerals of the soil. The key characteristics of this type of erosion is occurring gradually than the other types of erosion. On the other hand, if the water flow occurs suddenly in a small area, causes the creation of small channels named reels. This finally leads to reel erosion. At the final stage, the gully erosion occurs when the water flow creates deeper channels and leads to serious erosion issues. 5 factors affecting the soil erosion based on Russell model. First, rainfall erosivity, named R factor and refers to annual precipitation pattern. The second one is slope length, named LS factor and refers to topography and its role. The third one is cover management, named C factor and refers to land use practice. The fourth one is control practice, named P and refers to the effectiveness of conservation practice. And finally, the soil erodibility, named K, and refers to characteristics of the soil. This is the literature review of our paper. In 1997, Reynard concluded that the Russell continues to be widely employed, particularly when compared to complex models like the water erosion prediction projects. In 2003, Engema concluded that the soil erosion models have proven to be valuable for simulating erosion processes within watersheds, accounting for the complex interactions influencing erosion rates. In 2009, Pimentel et al. Said erosion in basin areas lead to the removal of vital topsoil layers, resulting in diminished arable land. In 2001, Nyakatova et al. Concluded that the soil erosion often carries valuable nutrients, pesticides, and harmful agricultural chemicals which find their way into rivers, streams, and groundwater resources. These are research questions that I want to answer them all by the end of this presentation. The first one is, what is the current average annual soil erosion rate in Clay County, Minnesota? The second one, how does this rate vary across different regions of the county? The third one is, how do variations in rainfall patterns contribute to soil erosion in different parts of the study site? The fourth one is, what is the impact of different soil types on erosion erodibility in the study area? And the last one is, how do slope length and steepness interact to influence soil loss in specific landscapes? The methodology is consisting of different steps which illustrated here. We extracted slope, flow accumulation, land use, land cover, rainfall spatial distribution, land management, and soil map, and finally mapped the soil erosion rate of the Clay County. Our considered study area is Clay County, which is stated in western part of the Minnesota, United States of America. The land use mostly consists of agricultural lands because of being neighboring to the Red River. Average annual precipitation is 1850 millimeters and temperature reach the minimum rate by minus 18 Celsius and peaks the highest by 28 Celsius. About the data set, we use digital elevation model to extract LS factor, soil map for K factor, Landsat 8.9 for extracting P and C factor, and finally climate research unit data for the purpose of rainfall erosivity or R factor. As I said before, the Russell model consists of 5 different factors. These factors are being multiplied by each other and overlay them to produce soil erosion map. Here's our study results. The left figure shows the R factor, and as you can see, if the R factor goes up, the erosion rate also goes up. You see the rainfall erosivity scattered from west to east by 521 to 597. Western parts are less vulnerable to this factor, and this factor has the highest impact on eastern regions. Also, as you can see, the right figure shows the LS factor with the same as the R factor. If the LS factor also goes up, the erosive rate will go up. You can see the eastern and southeastern parts of this county has the highest slope. Also, the K factor is shown here with the same as mentioned factors. The K factor has the same behavior as the previous ones. The K factor in the eastern parts is higher than the entire parts, and in contrast, by increasing the P factor, the erosion rate declines. As you can see, there is no clear control practice distribution over the study area, but the eastern parts of the county which have higher values signify commendable implementation of soil erosion. And the final factor, which is named C factor, has the same behavior as the K and R, and also LS factor. The central to eastern sectors of the study site emerge as the regions of reduced vulnerability erosion owing to the conscientious deployment of productive land management practices. Here is our research result, which shows the soil erosion rate of the study area by Russell model. As you can see, southeastern parts of the Clay County, which has the most slope, is susceptible to severe soil erosion rate than the entire parts. Also, you can see the thick lines scattered at the different parts of the Clay County, which is susceptible to severe soil loss. But if we compare with the southeastern parts, it is negligible. Finally, we assessed the soil erosion rate and compared all of the influential factors with each other and concluded that the LS factor has the most impact and about 82% correlation with soil erosion. And about the conclusion, we can say we extracted all 5 factors and multiplied by them together and finally got the soil erosion rate of the Clay County. Thank you all for your attention, and special thanks to my Professor Noorani for inviting me for this valuable conference. If you have any questions, I attached my email to respond them all. Thank you.
Thank you very much, Dr. Mohammed Bejani, for your research and for sharing us. And also, it was good that you have shared your email for further questions. Next is Dr. Ezgi Shahin Yücel. Dr. Ezgi, you can share your screen whenever you are ready.
Sorry for the, I'm not really familiar with the tool and I'm trying my best to screen my share. Sorry
No
for
worries.
taking your time.
No worries.
I guess. I guess when I share my screen.
Yeah.
Can you see my presentation or?
Yes, if you open your presentation right now and right now we cannot see it in full
screen share mode. I guess I need to disconnect my second screen. And now, can you see it clearly?
Yeah, yes, right now, yes.
Perfect. Okay, sorry for the taking your time. Sorry, I couldn't be with you over there today, but then I'm in the Metsi as well. I am connecting with you from the Mersin, Turkey, and I'm a marine researcher at the Institute of Marine Sciences of METÜ. And then our campus is in a good collaboration with Nrsem University as well. And we are not only the Institute of Marine Sciences, but in our campus there are different infrastructures as a DECOSIM Climate and Ecosystem Center, and then now recently established Climate and Sustainable Development Center. And then our researchers are conducting marine research, not only in our coast, but also all over the seas of Turkey, and then at the poles, and then deep sea. And of course, we are trying to tackle the different regional global problems, major and challenging problems all over the seas and oceans. And then one of them are related to clean and healthy seas. As you all know, we are providing a lot of ecosystem services based on our seas and oceans. But then, of course, there are a lot of human in these problems, challenges, stressors all over the seas and oceans. And one of the prominent ones are the pollution, unfortunately. And then to tackle this problem, to understand its extent, and then try to find solutions and give them policy recommendations to the governmental bodies, we are conducting different research. One of them is under the integrated pollution monitoring, and the other one about plastics. And of course, beyond that, we are trying to build a sustainable blue economy and then serve for the global level strategies and action plans. And then under these programs, I just give some of them as an example. One national one is the Integrated Pollution Program, supported by the Environment, Urbanization and the Climate Change Ministry, and we are dealing with the Mediterranean cost of this program. The other one is under the DECOSYM program. This is Marine Ecosystem Climate Research Center, time series and offshore research program. And then again in the Mediterranean coast, we have detailed stations and then monitoring program since 2012. And then one other is really local to Çukurova region, and with the different metropolitan municipalities, we are conducting a huge program with the support of those local authorities. And then we conducted different research activities to tackle with the macro and micro level plastics. But now we have one constant monitoring program with the aerial drones. Since we are in our institute, we are in protected area. We are trying to understand the effects, even if the place is then under the protection. And then, as I mentioned, we are also part of international global level programs to tackle with them not only plastic, but also all kind of pollutions. And I also would like to give some details since we are in the ISMET. I mean, as I mentioned, this CleanMet has different approaches. Like we have marine and terrestrial input stations to observe all the input comes from the different sectors. And then the COSIM also has this detailed map of the tackle and understand the extent of the pollution problem. And of course, understanding and then producing solutions is one leg of this kind of research. But of course, it should be evolved to policies and then strategies, what should be prioritized to tackle with these problems. So we also have different programs under that extent. And now we are conducting one study together with the Çukurova Development Agency to make a map, create a map of the different sectors and then how we should manage them for a sustainable and, as you know, clean Mediterranean. And then the other leg of this kind of researchers, of course, we should also create an awareness for long-term strategies. I mean, if we have ocean literate societies without polluting the seas, actually we can reach our targets easier. So considering this, we are conducting educational programs since 2012, and then we reach more than 7,000 students and educators to raise awareness about the seas and oceans and then the climate. And another component I would like to share with you that before giving the hub activities, it's as Matthew, we are also leading different sustainable blue economy strategies and then the research programs. They are mainly in the Black Sea, but also as a Mediterranean Sea-based institute, we are doing all these efforts from here to increase capacity of our region, not only Black Sea but also Mediterranean Sea. And then now we also have different international global level tools like missions. One of them tackling, I mean, there are 5 different missions, but one of them is on the restore our oceans and waters. So the 3 of the main proposals is eliminating pollution. And then, of course, to implement this kind of missions, they have coordination and support actions. And then the main target of the Mediterranean Sea Lighthouse, this supporting mechanism, is again eliminating pollution and then making clean Mediterranean Sea. This supporting mechanism called is Blue Mission Met. We are also part of this as a Turkish representative, and this aims to inspire, inform, and mobilize all actors that can take role in preventing and eliminating pollution in the Mediterranean Sea. We all know the problem, but of course we need to develop a solution. I mean, now what's next? And to be able to do this, they are making an innovative innovation ecosystem. They are planning to design, structure, and support a well-functioning ecosystem for that. And then, of course, there are different initiatives and activities to disseminate and upscale solutions, but we need to gather all together. We should make them in a one umbrella and then share with the actors to make it. And then, of course, without covering all the actors, we cannot really manage our targets. So involving all stakeholders, reaching the general public is also essential part of making Mediterranean Sea clean. Here, I will just forward with the hub activities. Of course, there are different mechanisms in different countries, but in Turkey, we are aiming to reach this approach in a local, regional level, and of course, national level. And then our target is prevent and eliminate pollution in our region. And as you know, there are a lot of sectors who are creating this problem, but then we should also produce the solution altogether. So fishing and aquaculture, maritime transport, tourism, textile, plastic producers, solid waste and water treatment, civil society, and of course policymakers. We are all responsible what's going on and how we should tackle this problem together. And we are aiming to find produce technological innovation, business models, financial support, social innovations, and then, of course, support policies and action plans. And when I go low and then give more detail, this hub to tackle with the plastic pollution and then the chemical pollution, the main structure is then, of course, creating a broader network to have all these sectors involved and try to make a share the good practices and what we are doing all together and now what we can do next together, what is the opportunities, needs and gaps to tackle this problem. And then, as I mentioned, again, create an innovative ecosystem. And now we know the problem, but how to tackle with that. And we are trying to monitor the activities to create a better approach. And again, increase awareness about litter-free, clean Mediterranean altogether. And we started our activities recently in the 2023. We make one global level event and then share innovative transformative solutions under the Blue Mission Med. And now we recently established our Turkish hub. And we make a huge event together with all actors from the Turkish coast of the Mediterranean Sea, and then all the chambers, local authorities, and researchers and sector representatives came together and then share what's the problem in the Med Sea about the pollution, and then what we are doing. Different sectors, different researchers, they share their practices, and then how we can create them. Different projects all together, or how the authorities can support us for the funds. So we had a chance to discuss all of this together and then start to develop our next steps. Here I also would like to give some points everybody can benefit from this hub, how these hub activities can help everybody, researchers who is dealing with the pollution, benefit from these hub activities. Of course, you can expand and strengthen your network, sharing your activities, initiatives, solutions. It's a good platform for this. Meeting with relevant stakeholders, you can work with for the future activities, and networking with international actors related to clean seas and oceans. Sharing good practices information, as I mentioned, is a big part, because then you can benefit from what's going on in a global level and apply in your research. And developing new collaborations projects, sharing your activities also help this, and learning from the others, and obtaining opportunity to develop joint actions, project collaborations with easy access to relevant actors. And of course, one other important point everybody also highlights, we need a financial support to make things realize. So being part of this network and then sharing what's important, what should be the next, will also guide the next funds. So it's also opportunity to share your thoughts, your ideas, and in the future strategy plans, hopefully they will be to turn to solutions. Okay, I would like to stop here. I share my email in my presentation as well, so you can ask me if you have any questions later on.
Thank you. Thank you, Dr. Ezgi Şahin Yücel. It was a good presentation, honestly, and thank you for your attendance. Right now, that was the end of our session 2, and we will continue with session 3. Thank you for all. See you in session 3.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.